Hi everybody, welcome to Learn at JOES. In this episode, we'll go over the basics of pulse width modulation. Let's jump right in. Pulse width modulation, also known as PWM. Say we have a square wave function defined by a repeating period time which relates to the frequency of the signal. Within each period, there is a portion that is high and a portion of the period that is low. This duty cycle, referenced in percentage, drawn here as an active high duty cycle, can be adjusted or modulated to control how much output we want to drive to a load circuit. Here's a basic circuit of a load being switched by a PWM signal. The load is driven by a voltage, and the low side switch is toggled by the PWM signal from the microcontroller. A PWM signal with a lower percentage duty cycle will run the load at a lower output, while a higher percentage duty cycle will run the load at a higher output. For our application demonstration of PWM, we'll use the Arduino Uno board, which has an onboard LED tied to pin 13 on this board. Here's some quick and dirty code. I'll put this on the link in the description below. Now obviously this is not code that you want to use in an actual real application. It's just a quick and dirty demonstration of getting a PWM signal out without having to go through setting up timers and maybe some other peripherals that may be required on your chosen platform to get a PWM signal output. So as I said, we have a pin 13. We're going to set that to high output mode in the setup. And then within the loop, we're going to burn the CPU infinitely to toggle the I/O high, wait for a period of time, set the I/O low, wait for another period of time. Now if we add these two delays together, make sure they're up to 10, we'll get a signal of 100 Hz. And right now this is set for 50% duty cycle. Let's go ahead and set this to 1 and 9. 1 on, 9 off for a 10% duty cycle. We'll upload program and we'll look at the board here, and that LED is fairly dim. We can use the scope to confirm how we're driving that LED on the board. We see that we have a square wave signal and we're measuring a frequency of about 100 Hz, and in our case we have a duty cycle of 10%. Alright, back to the code. We go to the other extreme. We go to 9 and 1 for a 9% duty cycle. We see that LED is much brighter. And on the scope we see that we have a 90% duty cycle, give or take. And as always, thank you for watching. I hope you found this useful.